All right, let's dive right in. Today, we're talking about something that honestly impacts pretty much everyone every single day, even if you don't think about it. And that is software quality.
Yeah, exactly. And it really just comes down to this, right? You know those apps on your phone you absolutely love and the ones that just drive you crazy? What is it? What's the thing that separates the good from the bad?
Well, for businesses, it's huge. I mean, think about it. The market today is just packed. There are a dozen apps for everything. So if yours is slow or buggy or just frustrating to use, people are gone. They'll just switch to your competitor in a heartbeat. Quality isn't some nice-to-have feature anymore. It's literally about survival.
You know, you often hear people complain about how much time and money it takes to build good software. And I love this quote from Jerry Weinberg. He just asked, compared with what? It's such a powerful way to frame it because, yeah, quality has a cost, but believe me, the cost of failure, that can be on a whole other level.
And when I say astronomical, I am not kidding. Take a look at this number, $300 million. That's how much the Hitomi Space Telescope cost. And back in 2016, the whole thing was lost, just gone. Why? A bunch of software bugs. A $300 million satellite completely destroyed by some bad code. Now that is the cost of poor quality.
Wow, that is just a catastrophic failure. And you're right, it's not even just about that one giant price tag, is it? A failure like that has to ripple out in so many other ways.
Oh, absolutely. You've got the direct costs, right? The actual hardware, the lost data. But then there's all the indirect stuff. Maybe you get hit with contractual penalties, or you suddenly need to hire a ton more support staff. But honestly, the biggest hit is often to your reputation. Once people lose trust in your product or your brand, getting that back is incredibly difficult. That can sink a company.
Okay, so clearly the stakes are super high. We get it. But this brings up a really important question. We keep throwing this word quality around, but what does it actually mean? What makes a piece of software high quality? That is the million-dollar question, isn't it? So the official textbook definition is basically this: the degree to which a system satisfies the stated and implied needs of its stakeholders. The key words there are satisfies the needs. It's not about being perfect or having zero bugs. It's about doing what people, the users, the business, actually need it to do, and doing it reliably.
And that's because quality isn't just one single thing. It's actually a whole bunch of different characteristics all working together. You've got things like functional suitability. That's just, does it do the job it's supposed to do? Performance efficiency. Is it fast? Does it feel snappy? Or is it a resource hog? Then there's usability. Is it easy to use, or do you need a manual to figure it out? And you've got other crucial ones like security, of course, maintainability, which is about how easy it is to fix or update, and even portability. Can it run on different systems? To get a truly high-quality product, you've got to nail all of these.
That totally makes sense. It's kind of like a diamond, right? It's not just about being clear. It has to have all these different facets cut just right for it to sparkle. But wow, that's a long list. So how on earth do you even begin to check for all that stuff? How do you make sure you're getting it right?
Well, that brings us to the core of it, really. The main way we do that is through a process that I'm sure you've heard of: software testing. That's the whole set of activities teams use to check on and improve quality.
Okay, so testing. Does that just mean, developers finding and squashing bugs in the code?
That's a super common mix-up, but they're actually two separate things. Think of it this way. Testing is the process of finding the problem. It's about seeing the effect, like, hey, the app crashed when I clicked this button. Debugging is the detective work the developer does to go into the code, find the cause of that crash, and then fix it. Testing finds the what, debugging finds the why, and fixes it. You need both.
Right. And when it comes to testing, there are really two big ways to go about it. The first one is called static testing. Now, this is a bit different from what most people picture. With static testing, you're not even running the software. Instead, you're looking at the plans, the requirements, the design documents, the code itself. The analogy here is perfect. It's like proofreading the blueprints for a skyscraper to find problems before you start construction.
And then you have the other side of the coin, dynamic testing. This is what most of us think of when we hear testing. This is where you actually run the program. You're clicking things, typing stuff in, really trying to use it, or even break it. To go back to our skyscraper, dynamic testing is like after it's built, and you bring in a crew to do stress tests, shake the foundation, test the fire alarms, make sure the thing actually works as intended under pressure.
Okay, so static testing is for checking the blueprints, and dynamic testing is for stress testing the finished building. Got it. Exactly. And this is so important. You can't just pick one. You absolutely need both. Static testing is all about prevention. It's about finding those problems early, on paper. Dynamic testing is about detection, finding failures when the software is actually running. Two different goals, both totally essential.
And this circles right back to the money, doesn't it? Finding a mistake on a blueprint, that might be a 5-minute chat in a quicker race. But finding that exact same mistake after the skyscraper is built and people have moved in, that's a disaster. It's the same with software. A bug found early is cheap to fix. That same bug found by 1 million users, well, we've seen how that can cost hundreds of millions of dollars. The simple rule is, the earlier, the cheaper. Way cheaper.
So, this all leads to what might be the single most important point of all this. Quality isn't some checkbox you tick off at the end. It's not the job of one person or one QA department. It has to be a mindset, a culture. It's a continuous thing that everyone on the team is responsible for.
Yeah, you really have to think of it as a life cycle. It starts way at the beginning by making sure the requirements are crystal clear. Then you review the design to spot flaws before you even write a line of code. Then you focus on writing good, clean code. And of course, you verify everything works before it goes out the door. Every single step, every single person plays a part in building quality in.
Right, so you can't just slap a quality sticker on at the end of the assembly line. It's not an afterthought. It has to be baked in, woven right into the fabric of the entire process, right from day one. Precisely. And look, we live in a world that's all about moving fast, shipping features, getting things done. It's so tempting to just say, it's good enough. But as we've seen today, the potential cost of good enough can be anything but. So we'll just leave you with that to think about. In this fast-paced world, what's the real price we pay for good enough?